So we have a distributive property problem here. We know this is distributive property because we have one term on the outside of a set of parentheses, and inside those parentheses there are two terms. They are separated by that minus sign there. So we really have two small multiplications happening here. One where we multiply the root 10 by the first term, the 5 root 5, and another where we multiply that root 10 by the second term, the negative 2 root 2. So there's a bit more going on in this problem than we had in just the simple multiplication problems. So I like to include colors here. If you have highlighters, those are sometimes helpful. Multiplying that root 10 by the 5 root 5, and then also multiplying that root 10 by the negative 2 root 2. So two small multiplication problems here. We want to keep that product rule in account. We have a root 10 and a root 5 in the very first example. Those are both numbers under the radical, so we multiply those together. 5 is a coefficient, so it stays on the outside. 5 times 10 is 50. Again, that 50 is coming from the 10 times 5. Jumping over to the second set, same idea. We've got that product rule. Now it's a 10 and a 2. So the 10 and the 2 will multiply to give us a root 20. Keep in mind that root 10, that square root of 10 is a positive number. We're multiplying a positive by a negative, so the end result will be negative. Once again, the 20 coming from the 10 root 2. Thanks, Belle. So we have two radicals here that need to be cleaned up a little bit. We have a square root of 50 and a square root of 20. This is a good time to pull out that list of perfect squares if you don't have those memorized. 50 you can break up into a 25 and 2. The reason I'm picking 25 is because the square root of 25 is something we know. The square root of 25 is just 5. And root 2 is not a very nice number, so we just bring that down along with the 5. We want to be careful. One of the most common mistakes I see is for people to lose their coefficients, especially when that coefficient matches one of the other numbers in the problem. So we have a 5 that comes from the original 5 in this problem that we started with, the 5 root 5 here. We also get a 5 that comes out of the square root of 25. So we do want both of those 5s when we start putting together that final answer. Jumping over to the the right term, we want to break that 20 up. 20 you can break up into 4 times 5. Again, the reason I'm picking 4 is a perfect square. We know the square root of 4. Square root of 4 is 2. And the reason the 5 is there is because I needed them to multiply to 20. 4 times 5 gets me 20. Unfortunately, 5 is not a perfect square. It's not a very nice number. So that 5 is just coming along for the ride. Just like before, we don't want to lose the coefficient, nor do we want to lose the fact that there's a subtraction here. And we can do a bit more cleanup. So 5 times 5 is 25. The root 2 is still just along for the ride. On the right term, 2 times 2 is 4. And the root 5 comes along for the ride. So we have two terms here. It's really tempting to try to find a way to put these two things together. Unfortunately, on the right hand side, I've got a square root of 5. And on the left side, I've got a square root of 2. These are not like radicals, so we cannot combine them. In order to combine them, you need the same index and the same radicand. So because these two things are not alike, this is as far as we can go with this problem.